Hey everybody, Luke McElroy from Mets Performance Consulting. Welcome back to another episode of the Physiology Secrets podcast, joined today by Nick Jane Koskis. Today we're going to talk about the body as a whole, so oxygenation as a whole. So we had a topic come up. We reposted a very old video the other day through Instagram about altitude training masks and how they're actually really ineffective and that they don't simulate altitude. And we're seeing more and more products talking about nitric oxide and how that improves performance. So what we want to do is just talk about the three systems: the cardiovascular system, the respiratory system, and the muscular system, and how they all work together to improve your Vo2 Max or to improve your oxygen carrying capacity. So Nick, before we go into specific products, do you want to quickly roll through the pathway of oxygen from the lungs all the way through the muscles and how that sort of works?
Yeah, so very simply, like when we talk about this, and it's something we discuss a lot, is the whole Vo2 Max process, because essentially Vo2 Max is the ultimate ability of these systems to work together. So air starts outside the body in the atmosphere. We take a breath in, air comes into the lungs to begin with. Not all of that air is oxygen at sea level. 21% of it is. As you go up to altitude, we're getting less air, less available oxygen. That air comes into the lungs. We then diffuse the oxygen out of that air into the bloodstream. So from a respiratory perspective, it's just all about the rate at which we're breathing. So our respiratory rate, how much air can we get in per breath, our tidal volume, and those two multiplied together give us our ventilation, so much air we're getting in per minute. Once we get that oxygen diffused into the bloodstream, then it's about how well can we transport it. So we're now talking about, well, what is our heart's ability to pump blood out per beat? How well can we actually carry that oxygen through hemoglobin, the red blood cells throughout the system? How much blood have we've got to be able to transport? Is there more hemoglobin, less hemoglobin, etc.? That all then allows us to get the oxygen to where it needs to go. So whether that's getting up to the brain, whether it's getting into the muscle to be able to break down fuel and create energy. Once it gets to where it needs to go, particularly when we're talking about performance, looking at the muscle mainly, once it gets there, it's about how can we diffuse that oxygen into the muscle. So we have to have the pathways in which we can get oxygen moving from the blood into the actual muscle itself. Then also from just into the muscle, into the mitochondria, which is where all the energy production is going to occur. So really it's this linking component of, you can't just be really good at one system and neglect the other two, or be good at two and neglect one. And we see it typically with a lot of athletes who've got really high ventilation. They've got a great amount of air coming into their system. Really, they might be a big athlete, 6'4", 6'5", huge lung capacity, 200 litres, 220 litres of ventilation. Heart rate's doing pretty good. They're pumping a lot of blood around the system, but their ability to use it, the working muscle, is kind of letting them down. And so we might see in a metric in the lab, you've got some of our other stuff on FeO2, and their ability to extract the oxygen into the muscle and use it might be lacking. So their performance overall is going to be inhibited. Flip side of the spectrum, we might have someone who might have a really elite ability to extract the oxygen into the muscle, but their ventilation, say for example, is only 100 litres. Well, that could be part that's holding it back. Let's say we've got a case of, if you're a heavy asthmatic and you've got breathing restrictions, that's obviously going to limit the back end of the process because you can't get the air in the first place. So we're looking at a combination of systems working together to produce performance, rather than just, well, you can breathe lots, so you're going to be more aerobic. It kind of doesn't work in isolation.
Yeah, and I was just jotting down a couple of key factors in each of those areas that are important, and feel free to jump in with any more that come to mind, but this is just off the top of my head. So we need a good lung capacity, a max ventilation. How much air can you take in per minute? And then of that, we need good pulmonary diffusion. So yes, we're taking the air, but then we need to diffuse the oxygen from the lungs into the bloodstream. Then we talk about cardiac output. So that's to do with your stroke volume and your heart rate. So stroke volume being how big is that left ventricle? How much blood can it actually beat per beat? Times by heart rate is how much we're circulating. And in that blood, we talk about the hemoglobin concentration. How much hemoglobin is there? Because that's what carries the oxygen, which is directly related to your blood volume as well. When we get to the muscles, we need the capillaries to actually supply the muscles, so oxygenated blood at the muscle. Then we need the myoglobin to carry that oxygen into the mitochondria. And these things are very much determined by your fiber type. So slow twitch fibers being better than fast twitch fibers for that stuff, which is that genetic component. So as you said before, you might have really good lung capacity, you might have really good cardiac output, but then you've got all fast twitch fibers at the muscle when you can't extract the oxygen across.
Yep.
So there's lots of things that have to happen. Now the good thing is that, you don't just work on one or the other. If you go out and train, then Your pulmonary diffusion, so your oxygen from your lungs to your bloodstream will get better. Your cardiac outputs, your stroke volume will increase. And then whatever slow twitch muscle fibers you've got, they're going to get more capillaries, a little bit more myoglobin, and an increase in number, size, and surface area of mitochondria. So when you go and train, you're not focusing on a specific area. It all works holistically. But that's when we come into things like nutritional products and supplements, where it might boost one area, but it has no effect on the other. And then the one that's probably key right now that everyone talks about is this nitric oxide. So what nitric oxide does, and I'm not going to name products, mainly because I can only think of one off the top of my head, but I've had a few people send a few through to me, and one of them, I legitimately can't remember the name. It said like, this nitric oxide product improves your vasodilation by 43% or something ridiculous. So vasodilation meaning expanding of the blood vessels. So basically it's suggesting that it's going to, because you can vasodilate, your blood vessels get wider, you're going to increase your oxygen delivery. More blood flow, more oxygen delivery. Hey, more oxygen delivery means more oxygen in the body, more diffusion in the muscles, so on and so forth. But that's not necessarily true. Number one is, if you're a healthy person, I don't see why you would need more vasodilation. Because unless you're clogged full of crap,
excessively high blood pressure.
If you have really, really high blood pressure, it might help. But if you're a normal, healthy individual, then vasodilating is not really going to help. If anything, I reckon that would have a massive drop in blood pressure, because they're dilating so much, you might get lightheaded. But anyway, if there's a problem there, then it's going to improve performance. But if there's not a problem with your arteries, then it shouldn't really have much of an effect. So it might say a 43% vasodilation, and I don't know if that's true or not, but it's irrelevant, because nitric oxide, from the research I can see, does anywhere from no effect whatsoever to about 1.5%. So even if we had a 43% increase in vasodilation, if we're only getting a 1% in performance improvement, it's because this is purely going to help with the cardiac output equation. It's not going to help with your pulmonary diffusion. You're not going to breathe in more air or oxygen. You're not going to diffuse more oxygen. And at the muscular level, you're not going to diffuse more into the muscles either. It's purely that one element, but the other elements, the lungs and the muscles, haven't changed at all. So you're not going to change your oxygen consumption dramatically. Do you want to talk about, so that's one example. Anything to add to that before we move on to maybe Ventolin?
Probably not. Like you said, it's more so the case. Like if you're that, I guess, genetic endurance freak, where you high amount of slow twitch fibers, you got a really elite ability to extract oxygen naturally, but your cardiovascular system's very poor to average at best. Well, that's probably where I guess the only case in which you're probably going to see that 1% improvement is that, all right, well, we've just taken the handbrake off one of the systems. But again, is it doing a lot? Because if you just isolate one part of the problem, it's not really going to fix anything else. And if that's not the key part of the problem for you, that's holding you back, which for most athletes, the cardiovascular side of things probably isn't in most fit, healthy populations. It's probably more so that usage of oxygen aspect or somewhere else in the chain. Then it's kind of like, well, is it really worth it? Probably not.
And it's a different example, but one that is effective, but is illegal. You can't do it. Is taking EPO. So EPO is going to increase that hemoglobin count. So you will be able to transport more oxygen because you have more hemoglobin. But then also at the muscular level, because you've got more delivery, your muscles do adapt, and you get slightly more mitochondria as well. So you're actually focusing on two areas, primarily cardiovascular, but you also get a muscular adaptation. Hey, if you can fix two parts of the chain, then that's going to have a significant performance improvement. Which is also why it's illegal to do. You can't do it unless you go and do legitimate altitude training. But you're focusing on one part which isn't limiting already, such as your blood flow. That's not a limiting factor. Hemoglobin, hey, that could be limiting, because too much hemoglobin and you're going to have a heart attack and a stroke and all that sort of stuff. But it's going to carry a whole lot of oxygen. But there's no issue there. But then going back to a couple of years ago, Chris Froome getting done for using Ventolin or too much Ventolin. Do you want to go through that example and how it may or may not improve performance depending on the individual person? Yeah,
so like it was a bit controversial, wasn't it? Where it's like there were reports he was using, was it something ridiculous, like 3 or 4 times the dosage that he should have been for Ventolin? It was a large amount, but essentially for those who aren't asthmatics who don't know much about Ventolin's a bronchodilator. So all it's trying to do is just open up his airways, which for an asthmatic athlete who has some sort of restriction in the airway, it's going to be useful because, like we said, if it's a genuine inhibition to your take in, transport, utilize process, then we're going to be able to open up potential to get more air in, allowing us to potentially diffuse more into the bloodstream. that's going to be a win for you. So if you're an asthmatic and you have to take Ventolin, it's okay. In his case where he's taking lots and lots and lots, is it potentially going to give him an advantage? I'd argue potentially not, purely from the fact that if he doesn't change anything in his physiology from a transport in the oxygen or his ability to diffuse the oxygen into his bloodstream, or even on the back end, his ability to use the oxygen in the working muscle, having more air come into his system probably isn't going to do a hell of a lot for him. He's just going to breathe more air. It's just going to get into his lungs. And if he can't then, like I said, even extract that oxygen out of the lungs, diffuse it into the bloodstream through pulmonary diffusion, he's just breathing more air in for the sake of breathing more air in. He's probably going to end up breathing a lot of that back out. Like it might have, I guess, a psychological effect in terms of he feels like his airways are crazy open and he's really calm and relaxed as a result of that. That might aid his performance in a different manner. But physiologically, is it doing anything different? Probably not. Like, I'm not an asthmatic.
I think
if I took Ventolin, I'd just feel like I'd go for a run and be like, oh yeah, I feel like I can breathe really easy. But is that going to make me necessarily more aerobic? Well, no, because my muscles can only do what my muscles has been trained or genetically determined to do. It's not fixing that part of the problem. It's kind of I guess on the opposite end of the spectrum, it's kind of what happens with those training masks in a way, in terms of you're just restricting air coming into your system. You're not changing the percentage of available oxygen by changing the atmospheric pressure around you. It's just, I'm restricting how much air I can get in. So there's just less air. It's not actually doing anything in terms of the gradients of oxygen diffusing in. And that's where we're not getting an EPO stimulus and we're not getting a hemoglobin production as a result, like we would at altitude. So I guess on the opposite end of the spectrum, it's a similar principle. We're just focusing on one minute variable of the entire equation that really isn't going to change much because everything else doesn't necessarily rely on that one thing being better or worse.
Yeah, I think that's key. And I think we'll come to the altitude training mask in a sec, but jumping back to ventilation, you're right. It's isolating one part of the chain, the ventilation, the maximum amount of air that you can breathe in a minute. And again, if there's no problem, if you're not an asthmatic, it's not going to have a dramatic effect. So let's say, I don't know, let's say hypothetically, severe asthmatic, Ventolin might help 40%. It's probably realistic, 40% if you're a really bad asthmatic. So Ventolin is going to be a performance enhancer, but just gets you back to a level playing field, really. Whereas if you don't have asthma, let's say, even if it does expand your lung volume a little bit, or you've got less resistance, so you can expand, or so you inflate and deflate your lungs a little bit quicker. If there's a 10% improvement in that, it might correlate to a 1% improvement in performance. Just like with the vasodilating, if there's a 40% improvement there, it doesn't necessarily mean it's going to improve performance that much, because it's isolated to that. So it's just the respiratory system in this example. So Ventolin, yes, if there's a problem there, just like if you've got clogged arteries, if you got blocked lungs, I'm an asthmatic, and I guarantee you it helps me. Then Ventolin's going to be really effective. If not, then I think it still can, but like we're talking 1%, not 10%, like it might for an asthmatic. But that's why it's restricted. It's not banned. It's because it's required to get a level playing field for those that have asthma, but it's restricted. There's no point to have 4 times as much as the normal limit or anything like that.
Yeah, and I think on that point as well, like it's quite common to see reasonable level endurance athletes who are asthmatics, and people might go, well, is that a case of just their Ventolin is doing all that work and that's how they get the better? It's like, well, we have a look at what they've done and all the training that they're doing. Let's say you have this restriction, you can't get as much air into your system, but you're still going and doing the aerobic training to maximize how much you can use at the working muscle, maximize how you can transport it. Well, then when you add the Ventolin on, now it's like, okay, we might get that 1% better, but that's just now getting you to a more normal state as anyone else. Yep. So they've still gone and done the training to be able to improve every other part of the chain. Yep. It's just, we're then just bringing up what their ventilation can get to, and alleviating that natural restriction. And that, again, that's why Ventolin's not necessarily banned. There is limits on how much you can take to fit in with medical guidelines and things like that. But at the end of the day, it's the type of thing that if an athlete has a genuine issue, then it's fine. But if you're an average athlete who doesn't have asthma and you're going out and trying to use that as your 1%, you better off spending your time and effort on what you're doing in your training and somewhere else, because it's not going to be. It's not the type of thing that's going to change your performance by 10, 15 minutes. Yeah. It'll be like, it might, like I said before, it might just make you feel a little bit better or more relaxed, and away we go as a result of that. So,
yeah. Yeah, and I think I'd say we're talking about some supplements that maybe don't really work in the sense of the whole body as a system. So Ventolin, nitric oxide, very little benefit if there's no problem with the body, so to speak. But then there are other ones, and I want to come back to altitude mask in a sec, but while we're on a roll, there are other ones that obviously do have a significant benefit, caffeine being a good example. Pros and cons of it. Caffeine is a diuretic, so it will dehydrate you, but there's an abundance of research to show that caffeine will help with late fatigue. So if you're an endurance athlete doing whatever 2-3+ hour events, caffeine has been proven to keep calcium being released from what we call the sarcoplasmic reticulum. Doesn't matter.
Yep.
We need calcium in the muscles to contract, and as we fatigue, particularly late fatigue, so when we get really fatigued, that calcium stops or gets released in smaller amounts, and that's going to slow our muscular contractions. But caffeine actually keeps that going for quite a lot longer. So something which actually doesn't change your lungs, your heart, or your muscles, it's changing your metabolism by caffeine. That has a really significant benefit in late fatigue, so long as it's counteracted with the right hydration as well.
Yep.
So we're not saying supplements are rubbish. Some are, some aren't. Supplements have a specific goal, and I think the key is just understand what that goal is, and then strategically use that in your training. It's just like bicarb loading. Okay, technically it works. Get it wrong, gastric upset, vomiting, diarrhea, not going to have a performance benefit. But if you get it right and you do it for the right event, it can work. So pros and cons to all these things. All right, let's finish off by talking about the altitude mask. The reason we had this is that we put up some content from a long time ago, about 3 years ago now, I reckon.
Yeah, a while ago.
Talking about these training masks, altitude training masks. They got sued for calling it altitude training mask because it doesn't simulate altitude. All right, Nick, just take us away and talk about very quickly an overview of what we're talking about with what an altitude training mask is, and then why it doesn't improve performance.
Yeah, so I briefly mentioned it a little bit earlier, but essentially what you're doing is you're putting on you're putting a mask on your face, and there's a little filter in it that essentially restricts how much air you're getting into your lungs. So I always like to use a bit of a silly analogy of if you tried to do your run and you were just breathing through a straw and put a peg on your nose, that's kind of what an altitude mask is doing. It's just restricting how much air you can intake. What it isn't doing is it's not changing any of the atmospheric pressure around. It's not changing any of the what we call the pressure gradient. So gases as a whole, so something like oxygen, is going to move from high concentration to low concentration. It's not changing any of that. So when you go up to altitude, the atmospheric pressure is lower. We have low pressure in the lungs when we're about to breathe in. If it's going low to lower, it's a much lesser process. Whereas down here at sea level, we've got a good high pressure of oxygen or high amount of oxygen outside the body, low internally. So if I breathe out and I've got low amount of oxygen in my lungs, oxygen wants to flood in, essentially. That's the very simplistic way of looking at it. Whereas altitude, it's a lot more difficult, purely from the fact that there's just less air, so that pressure's less so, and it's a much slower or lesser process in. Altitude mask isn't going to change that key variable, and that's the variable that pressure change is the one that's going to be causing most of the adaptations from an altitude perspective. So that's where our body has to go, all right, I'm getting very minimal amount of oxygen into the system. What do I do to make the most of the oxygen that is being, delivered into the system, and make the most of pulmonary diffusion, make the most of how do I transport it? That's where naturally occurring EPO is stimulated. So we get more red blood cells, more hemoglobin. We can transport the oxygen to the working muscle a little bit more effectively. We then come back down to sea level after being at altitude for a while. We then have much better or higher pressure of oxygen outside. So then the body goes, wow, this is really easy to get oxygen into the system. We can make the most of those red blood cells that have been developed through that altitude process. Using a mask, again, isn't changing anything external to you. It's just restricting how much air you get in. So there's no change in pressure gradients. Therefore, we're not really getting that stimulus of EPO. Therefore, we're not getting any of those benefits from altitude. You're just really doing two things. You're making the session harder from an exertion perspective. So if you're running at what would normally be a 7 or a 6 out of 10, it probably now becomes a 7.5 to an 8 out of 10, just because you're not able to get as much air in. So you probably have to rely a little bit more sort of potentially anaerobically, but you're just going to have to be breathing harder and potentially more frequently to get as much air in. And the other component to it as well is if we do look at some positives, there has been a little bit to show, particularly in chronic patients, or clinical populations of respiratory muscle training. Someone who's been through a really severe accident or some sort of medical condition that's caused them to lose a lot of strength or I guess, size of the diaphragm, the intercostal muscles between your ribs, and their breathing is severely inhibited. There is a little bit of research to show that like doing some work, short periods, is going to enhance the strength of those muscles and allow you to breathe a little bit more back to normal. In a healthy population, probably not as much, because you going out and pushing yourself and doing a VO2 interval set where you're breathing hard and quickly anyway is probably going to be enough of a stimulus there. And then really the only other thing we've seen in terms of positive is maybe in combat sports like mixed martial arts, where guys are being sort of choked out on the floor in their training sessions. Instead of actually having someone wrap their arm around and compress the airway, they just put a training mask on. So it kind of simulates that part of the sport for them from a specificity perspective, but it's not physiologically necessarily training anything. It's just getting them in a much safer way of, I guess, simulating what they would go through in their event. So endurance athletes, again, something I wouldn't really worry about and looking into. But that's I guess, a brief overview of training masks. And yeah, check out the video that we did put up, because that'll take you through it in a little bit more, I guess, depth. That's the sort of the rushed version.
Yeah, cool. I'm just going to share my screen. I've got on paint.
Good as.
Hopefully people are watching and not listening. I'll try to explain it for those that are listening to the podcast. But I've got at the top, this is me doing with my finger on the touchscreen. So normal sea level environment at the top and altitude at the bottom. So basically what we're saying is we've got outside the muscle and inside the muscle. Whether you're at normal or altitude, the starting concentration inside the muscle is 6, I've just made it up, 6 oxygen molecules. So you've got 6 at normal sea level and we've got 6 at altitude. But what changes is the pressure of oxygen in the outside air. So in normal, I've drawn about 20 of these oxygen molecules in the normal environment, because when we go to altitude, there's less pressure of it, there's only 10. So if you think about the net movement, think of these as rooms. You're at a party or whatever it is, and you've got 50 people in one room and 6 in the other. You want to move out of the crowded room into the other room. You want to even it out. So in a normal environment, we've got 20 oxygen molecules outside the muscle and 6 in, then we're going to even it out. And I don't know what the math on that is, Nick, but it means about, 14 or so are going to move across, something like that.
Something like that.
We get the point. So let's say there's 14 that way. That way it's even on each side, all right? Whereas in the other example, we've got 10 on one side, 6 on the other. Well, they're going to even out to be 8 on each. So we're only going to have 2 come across here to make it 8 and 8. So the diffusion is a lot higher in the normal situation, because there's more outside the muscle, less inside the muscle to even it out. 14 is not right.
14 is not right, but that's it. We get the general idea. I think
26.
In terms of, there's more available outside, and therefore it's gonna be much, I guess, more likely or more wanting to move to that quieter space, if you like, or the less crowded space.
It should be 7 at the top one.
Yeah.
7. That way, if it's 7 goes across, it means we've got 13 on each side. Whereas at the bottom, we're going to have 8 on each side, because there's less on the other side. So if you're watching that's going to make a lot of sense. But my point is, if you have an altitude mask on, which isn't really doing anything, you're still in this top one, this normal environment. You've got the same oxygen molecules, percentage of oxygen molecules, just less air overall. But it's not going to change that pressure, that diffusion gradient. So it's not actually stimulating altitude at all. When you do go to altitude, do it, whether it's a tent or whether it's training or whatever it is, that's when you go to this second one, when we actually have a lower oxygen outside the muscle. Therefore, we have less diffusion inside the muscle, and that's where we get the EPO benefits, which we know is going to help both the cardiovascular system through hemoglobin, and then also a little bit the muscular system to use up that extra oxygen. So apologies if you're just listening to that, because that probably doesn't make a whole lot of sense. But if you're watching it, that should make a bit of sense. And say we'll link that video as well, which went out last week. All right. Anyway, or can we do a summary?
I think that's pretty much it. I think really the key take home from my end is really we have to look at the holistic system. We need to understand that things, although we can describe them in part, we can describe the respiratory system by itself or the muscular system by itself. When we're working, we're training, and we're improving, they're working together. You can't just have one system outworking the others, and that's going to fix all your problems. It's all systems are going to interconnect, and we have this, I guess, this circle or cycle of the systems working together that's going to produce the output, as opposed to just one being the dominant. So keep that in mind. You might get minor improvements here and there, but for those big improvements we want to see in performance, or the big changes that everyone wants to chase, we have to consider that all systems are involved in that process.
Yep, I couldn't say it better myself. I think that's it. So, you know, you're not going to improve a lot by isolating a system. We want to focus on all the systems. Naturally, through training, you're going to focus on all three systems. You can't sort of target one but not the other. But then if you talk about supplements, Ventolin, nitric oxide, etc., very little benefit unless there's a problem in that circulation. So high blood pressure, or you're an asthmatic, for example. So those sort of things aren't going to work for the healthy people. There are some supplements that do work, such as caffeine and EPO, but obviously EPO, you can only do it if you've got altitude training. That's the only legal way to do it. So isolating a system is not very effective. The key is to get multiple systems improving together, and that's how you're going to significantly improve your performance. That's it for today. Hopefully you enjoyed that one. Please post any questions below, and we'll speak to you on the next episode.